Okay, good afternoon all. This is our second session on the subject plastic engineering. In this session, I will start the first chapter, that is introduction to the plastics. Okay, so before starting the actual syllabus, just I will take the review of the previous session. In the previous session, we have discussed this part. There is syllabus content. How many chapters are there? In that, I have given this course introduction. What are the actual contents, or what we are going to discuss in this plastic engineering subject? Okay, some course prerequisites. Prerequisites means we are considering that this knowledge is already with you. Okay, already you have studied these subjects, and these subjects will help you to understand plastic engineering. Okay, and in that, these are the subjects: engineering chemistry, then some introductory knowledge towards the polymers, then basic knowledge of manufacturing processes, then knowledge of the welding processes, and some basic knowledge related to the design. These are our prerequisites. And if you are not aware of these things, please try to take one revision on this. Okay, so that you will understand the plastic engineering subject in good manner. Okay, so after discussing this, we have discussed this: what is the course objective, why we are studying the plastic engineering subject, and we are having these course outcomes. Okay, after completion of the plastic engineering subject, you will be able to select the suitable plastic material. Just means what will be here, just I will tell you the application. I will tell you I want to manufacture this product. Then you have to choose the suitable plastic material. Okay, if you understand this subject very well, then and then only you can give the answers to these questions. Means after finishing this plastic engineering subjects, you will be able to do the selection of the plastic material for the end user application. Then you will be able to suggest the suitable processing method. Okay, it may be molding process or some welding techniques. And at last, you will be able to do the design. Okay, design of the simple plastic parts and design of the compression and injection mold. Okay, this is your means this will be your outcome. And to get this outcome, we are going to discuss 6 chapters. And out of that 6 chapter, this is our first chapter, introduction to the plastics. And these are the syllabus contents. In this first chapter, we will discuss the definition and classification of the plastic material, along with the properties of plastics and some applications. Then how to do the testing of the plastic materials. Then what are the additives? What is the meaning of additives? And what are the different types of additives which we are using in the plastics? Okay. Then what is the meaning of monomer? What is the meaning of polymer? And what is the polymerization? Okay. And in this, different types of polymerizations are there that we are going to discuss. And after that, applications of the plastic materials in specific fields like agricultural field, packaging field, then building, or you can say the construction field, then transport, electrical and electronics field, then medical and furniture field. Okay, just we are going to discuss the specific applications. This is the syllabus for first chapter, and already other syllabus we have discussed in the previous session. You can go through the recorded link of that. These are some practical work which we are going to finish, and these are the books recommended. Okay, all these books are available in our library. You can collect these books. Okay, so this is these are the actual contents of our first chapter, that is introduction to the plastic. And the very basic part here is the definition of the plastic material and its classification and properties. These first 2 points we will try to finish in today's session. Okay? I'll try to cover these 2 points in today's session. What is the meaning of plastic? How these plastic materials are classified? And what are the general characteristics of the plastic materials? Characteristics means properties only. Okay. So this is the first slide. In this, I have added a few points related to the what is the meaning of plastics. As per our tradition of our college, here I have added some slides. You can refer that. The title of the chapter, then central idea of the chapter, importance of this chapter, and chapter outcome. And after that, actual syllabus will be there. Okay. Within a few minutes, I will cover this slide and we will start the actual syllabus. Okay. Now, I'll try to cover the definition in this introduction only. So, what is the meaning of plastic material? Can you tell me? Anyone from who have joined from the online? Okay, or you people? What is the meaning of plastics? Any idea? You are surrounded with plastic materials only. And what is the meaning of exactly meaning of the plastic material? Okay, before going to that, I will first tell you from where that plastic word is derived. Okay, from where that plastic word is derived. Please refer the last point. Please read it. The word plastic is derived from the Greek word. Okay, from the Greek word plastikos. Okay, from this Greek word plastikos, we have given the name for that particular material as a plastic. Then what is the meaning of this plastikos? Plastikos meaning that particular material is capable of being shaped or molded. Okay. Whichever material, suppose one material is there, and if that material has a property, means you can give the desired shape and size. Means that material can be reshaped or remolded or molded or shaped as per your desire or depending on your application. Then it will be termed this as a plastikos. This is the Greek word. Okay, and from this Greek word plastikos, we have given the name plastic. Are you getting this? This is not the definition, just I am telling you from where that word is derived. Okay, because that material is capable of being shaped or molded. We can give the desired shape and size, and that particular property is known as plastikos in Greek language. And from that, we have given the word that is plastic. Okay. Here they have given that process name. Okay. That is plastos, meaning molded. After giving the shape, that material will be termed as plastos. But these are Greek words. Okay, this is just for your information. You can say that this is the little history of the plastic material. From that, I have explained you why this, where this word is actually derived. Okay. If you are having any query, language मध्ये वगैरे काय problem नाही ना? If you are having any problem in the language, you can tell me at the start only. According to that, I will make changes. Okay. I can continue. Okay. So now, in this way, this plastics word is derived. Okay. The material which can be shaped or molded. In Greek language, it is termed as plastikos. And from that, the word plastic is derived. Okay. Then, what actually plastic is, you can say that plastics are a wide range of synthetic or semi-synthetic materials. Wide range of synthetic or semi-synthetic materials. Then what is the meaning of synthetic or semi-synthetic materials? Synthetic or semi-synthetic? Synthetic. What is the meaning of synthetic or semi-synthetic materials? Synthetic or semi-synthetic material means we are doing some chemical changes. Means whichever material is naturally in existence, in that we are doing some chemical changes. Artificially, we are changing it. That is termed as synthetic or semi-synthetic material. Okay, are you getting this? There are some polymer materials. Okay, there are some polymer materials, and in that we are doing some chemical changes. Okay, that is nothing but these are synthetic or semi-synthetic material. We are changing the organic material already available. That's why it will be termed as synthetic. We are changing its chemical, and that will be termed as synthetic or semi-synthetic material. And we are doing these changes in the already existing polymers. Okay, there is a difference between plastic and polymer. Plastic is different and polymer is different. Means I will tell you one sentence, which all plastic materials are polymers. Are you getting this? All plastic materials comes under the category of polymers, but all polymers are not plastic. Plastic हे त्याचे एक सब टाइप मध्ये येईल. Polymer material can be classified as plastics and other materials like this. Means all plastic you can consider them as a polymer, but polymer may be a plastic or it may be other type. It means plastic is nothing but it is a polymer where we are making some chemical changes. This is one definition. Okay, means plastics are a wide range of the synthetic or semi-synthetic materials that uses polymers as their main ingredients. Okay, this is one definition, and it is a little bit difficult. So I have added some short definitions. You can refer that. This is just for your introduction. Okay. Then here one more point I have added. The plasticity during the production makes it possible for the plastics to be molded, extruded, or pressed into the solid objects of various shapes, making it an adaptable material for many different uses. What is the meaning of this sentence? The plastic material can be converted into different shape and sizes because of its plasticity. Are you getting this? Due to the plasticity of the plastic material, that available raw material can be converted in different shapes. That raw material can be converted into cup shape. That same raw material you can convert it into bottle shape or in the box shape. Means by using different processing methods. Here they have given the words molded, extruded, or pressed. You can use different processing method and you can convert the available plastic into different shapes and sizes. Okay, because of its very good or high plasticity. Plasticity मुळे काय होतं तर आपण त्याला वेगवेगळे आकार देऊ शकतो. It can be reshaped or remolded. Okay, that is the plastic material. The material which can be easily shaped or molded, that is also known as plastic due to its plasticity. Okay, this is also one definition. You can write this definition. Means try to understand that you can convert that plastic material into desired shape and size depending on your application needed. So I will move towards the next slide. Now this is the central idea of this chapter. What we are going to cover under this first chapter. So in first chapter we are going to cover the introduction to the plastic, means what is the meaning of plastics, then classification of plastic materials, properties of plastic materials. Then there is one term, polymerization method or process, polymerization. And what is the meaning of polymerization and what are the different types of polymerization that we are going to discuss in this first chapter. Then how to do the testing of the plastic materials. Okay, as we have performed the testing of metals and their alloys. Okay, we have conducted tensile testing. We have conducted tensile testing, impact testing in metallurgy subject. We have conducted that for metals and their different alloys. Now, then in the same way, how that testing is done for the plastic material. Different testings are there. Okay, flexural testing, impact testing, tensile testing. What is the procedure to conduct that test for plastic material? That we are going to discuss in this chapter only. And at the end, applications of the plastics in different areas that we will see. Then what is the importance of this chapter? After understanding the basic concept of plastic material, then its property and how they are formed, then and then only what I can say, I will be able to decide its application. Okay. For understanding the application of a particular material, first you should learn the basic of that material. Okay. In that, we are going to discuss the concept, then its properties, classification, and after studying this, then and then only I can decide the application. Okay, that's why this chapter is very important, and it is added in your syllabus. And then at the already I have discussed this. At the end of this chapter, you will be able to do the classification of plastic material, and you can decide their properties also. Then you can select the suitable method for the testing of plastic materials. Then you will be able to understand the concept of polymerization, and you can select the suitable plastic material for end application. Means after studying this first chapter, you will be able to understand the property and application and polymerization concept. Okay. So this is the first part. Already I have discussed this. Okay, plastics are wide range of synthetic or semi-synthetic materials that uses polymer as an ingredient and can be reshaped or remolded using heat and pressure into the solid objects of various shapes, making it adaptable material for many different uses. Okay, this is your plastic material. I will repeat it or summarize it. Plastic is synthetic or semi-synthetic material. Okay, means some small chemical changes we are making in it, and after that we can give desired shape and size using different methods. Okay, and okay, this word is very important. It can be reshaped and remolded using heat and pressure or combination. That will be considered as plastic. Are you getting this? If you are having any difficulty, you can ask me. Okay. So here one short definition I have made. It is a material belonging to the family of organic material and which can be reshaped by heat and pressure. Short. You can do the reshaping with the help of heat and pressure. Some examples of plastic materials are PVC pipes. PVC pipes, I think you have seen these PVC pipes. Whichever pipes are there in your drainage system, in your house, in the drainage system, to take waste water from our home. Pipes are there. Okay, that PVC, that are nothing but PVC pipes. This PVC is nothing but polyvinyl chloride. That white colored pipes we are using, these are nothing but your PVC pipes. Okay, then nylons, acrylics, polyesters, then polyethylene, polypropylene, polystyrene. Okay, number of, from this polyethylene we are having polyethylene bags. Polyethylene carry bags are there. But polyethylene bags are examples of these plastic materials. Okay. So this is the little introduction related to the plastic material. Okay. Here I have added some points so that you can understand what is the meaning of synthetic material. Already I have explained this. Some chemical changes are done. Okay. In short, what are the synthetic materials? These are made by chemically changing the already existing materials that are synthetic material, and this plastic is nothing but your one synthetic material, and that can be reshaped. Then properties of these plastic materials. If you are having any doubt or query, please ask me. Those who are attending lectures through online mode. Rahul Gaikwad. Rahul Gaikwad, are you there? So please change your name as per the other standard format. Write division and roll number and then your name. Any query? Okay. Now we will move towards some general properties of plastic materials. Okay, these are some general properties of plastic materials. What are the properties of plastic materials? Whichever plastic material you are using, what are the properties? Try to think from your own. Whichever plastic materials you are using in your day-to-day life, what are the characteristics of that material? You are using different plastic materials. What are the properties? Chairs are there. Chairs. You can say that they are very light in weight. Plastic material is very light in weight. Then their cost is also low. Okay, their low density and low melting point. This is the first property of the plastic material. Then their cost is very low if you compare them with the metals. Metals are having very high cost. Then whichever plastics are there, they are easy to do the means their manufacturing is very easy as compared to the metal or other materials. Then whichever plastic components are there, their life is very high or long life is there. Whichever plastic materials you are using, they are very durable, and we can manufacture these plastic components with variety of dimensions. If suppose plastic chairs are there, that chairs are available in different dimensions from small size. For children, they want small chairs, and small chairs are also there. And for adult persons, little bit larger dimension chairs are also available. Then benches are there. Okay. Whatever plastic material is there, means variety of dimensions can be easily achieved. Are you getting this point? You can give desired dimensions and they are very durable. Their life is very long. Long life is there. Plastic materials or plastic components. Then plastics are lighter in weight, but with lighter in weight, they will provide you better strength. They are light in weight, but they also provide the strength. Means if you take the chair, it can carry weight of 80 kg to 100 kg easily. Easily it can carry that weight. Means as if you compare its weight to its load carrying capacity, it is having very high load carrying capacity as compared to its weight. Okay. Though it is lighter in weight, it can carry larger loads. Then whichever plastics materials are there, they are very means they will provide you very good resistance to the shock, corrosion, chemicals or waters. Okay, means whichever plastics are there that will act as an insulator. Plastics means they are bad conductor of electricity. Okay, you cannot pass the electricity to the plastic materials. That's why we are using them in the number of electrical applications, or lots of electronic devices are made from the plastic material only, because they will act as an insulator or they will provide the very high resistance to the corrosion. Okay, what is the meaning of corrosion? Corrosion. Okay, corrosion means degradation or loss of the material when it it comes in contact with any medium. Okay, if it is a liquid medium, suppose uh, steel material is there. When it comes in contact with the seawater, material loss will be there. Some material will get eroded. Okay. So, if you compare the plastic material, they will provide better corrosion resistance as compared to the metals. Then shock resistance is also good. Okay. So these are means whichever corrosion resistance or shock resistance is there, it is very good property of the plastic material as compared to the metals or their metal and their respective alloys. Then plastics have good mechanical properties. Good mechanical properties means their strength. Tensile strength is very high. Already I have explained you. Okay. Then plastics have good ability to flow in the mold. Okay. It can flow readily. Means due to its flow ability, we can give the desired shape and size. Okay. If you give the slight heat to the plastic material, it starts melting, and you can do the desired reshaping, or you can give the any desired shape. Okay. So next property is the plastic material can be processed with the very less time. The processing cost means whichever manufacturing process we are using to give the desired shape and size, its time will be less and its cost also less for the plastic material. Then these plastics have good chemical stability and damping factor. Chemical stability means due to the environment, its property does not get affected due to environmental condition or surrounding condition. So these are some general properties of the plastic materials. Then we'll move towards the next slide. Okay, here these are here. Please consider it as plastic. Okay, plastic. Okay, classification of the plastic materials. Plastic materials are classified in two types. First is thermosets. Okay, plastic materials are classified in two types. First is thermosets or thermosetting material, and second type is thermoplastics or thermoplastic materials. Now, on which basis this classification is done? That I have explained in this slide. Sorry for disturbance. Okay, now you can see clearly here. Two types are there of plastic materials: thermostatic plastic material and thermoplastics. Okay, now please read it carefully. These thermosets or thermosetting plastic materials, these can be means you can say you can do the molding process only once. Okay, you have to provide the heat and it will be cured, means desired shape and size will be given. Then you cannot change its shape again. Only once it is possible. Okay, this is the basic difference. That kind of plastic materials are termed as thermosets or thermosetting plastics. Okay, are you getting this? Only once it is heated and it is cured, then you cannot change its shape. Only once it is possible. Here you can read it. Means these are the polymers that once molded and hardened cannot be reshaped or recycled. Okay, you can do the molding, means we are going to provide heat and its hardening is done. It will get the desired shape and size. Then over. You cannot change its shape again. That will be termed as thermostatic plastic materials. Then the second type of plastic material is thermoplastics. Okay, now to this thermoplastic materials, you can do the heating and molding process number of times. Number of times you can give the heating to that material and give the desired shape and size. Suppose after some time you feel that I want to change its shape and size again, then again you can give the heat and again you can do the reshaping or remolding. Means repeatedly you can perform heating and molding operation again and again on that plastic material. That plastic materials are termed as thermoplastics. Okay, and all these processes or heating and molding you can do without changing their chemical and physical properties. Without changing their chemical and physical properties, again and again we can do the heating and molding. Then that particular plastic material will be termed as thermoplastics. Okay, this is the basic difference. Are you getting this? Plastics are classified in two basic types. Okay, number of types may be there, but depending on their ability to do the reshaping or molding, we have classified them into two types: thermosetting plastics and thermoplastics. The plastic materials that once molded and hardened that cannot be reshaped are termed as thermosetting plastic materials, and the plastic materials that can be repeatedly heated and molded without affecting their physical and chemical properties, it will be termed as thermoplastic materials. What this? This is basic classification. These are two types. Now, each type has some specific properties and specific applications that we will discuss. At the end, I have added one comparison slide also. Okay. If you are able to remember this one slide only, it is also sufficient. Okay. On this left side, I have added thermostatic plastics, and on the right side, thermoplastics with examples. Okay. This is comparison chart. Whichever points we are going to discuss in these two slides or 3-4 slides, that I have summarized in one comparison. Okay, directly we can refer that also. But for better understanding, separately I have added these points. These are some properties. In your syllabus, only comparison. If that comparison points you are able to remember, that will be sufficient. This I have added for your knowledge only. Okay, these are extra points. So here you can see the properties of thermoplastic materials. These thermoplastic materials, you can see here, whichever bond is there, this first point is related to the bond. Okay, some molecules are there, whichever plastic material is there. As in your metallurgy subject, we have studied that whichever material is there, it consists of basic units. Okay, unit cell is there, and that unit cell is repeated. We have studied the crystal structure, and similar to that, molecules will be here. Okay, and that molecules are joined with bonds. Different molecules are there. This is one molecule and this is second molecule, and bond will be there. Okay. In both materials, in thermoplastic as well as in thermosetting material, bond will be there. Okay, this is the diagram. Okay, These are the molecules, and this is the bond. Are you getting this? These are thermoplastic materials, and these are thermosetting materials. Okay. Now, whichever bond is there between these molecules in thermoplastic material, this bond is weak. It is very weak if you compare it with the thermosetting materials. Whichever bond is there in this thermosetting material, this bond between the molecules is stronger. Are you getting this? Bond between thermoplastic material is weak, and bond between this thermosetting material is strong, or stronger bond is there. And due to this weak bond, as bond is very weak, we can do the reshaping again and again. As bond between the molecule particles is very weak, you can provide slight heat and you can do the reshaping again and again. But in case of thermosetting material, that bond is very strong between the molecules. That's why we cannot do the reshaping again and again. Okay. This is basic difference related to the molecule bond. And depending on these basic structures, you can decide the properties. Okay. Here, the molecules have weak bond and straight chain bond. That's why it can be broken by heating. Okay. Then these thermoplastic materials, are depolymerized by the manufacturer, and they don't require polymerization process again and again during the processing. Okay, for this polymerization, separate 1 or 2 lectures I am going to conduct. That's why I will not explain it here. Just try to understand that whichever polymerization process is there, that during the processing of thermoplastics, we are not going to use it. During processing, before that processing only, all polymerization will be completed. Then these thermoplastic materials, they are elastic and flexible in nature. Then they can dissolve in the organic solvents, means they are soluble in the organic solvents. Then on heating, they will soften. Whenever you are providing the heat, they will become soft. And after large amount of heating, it will get melted. Okay. Then the melting point of thermoplastic material is lower than their degradation point. Degradation points means at that temperature, it will be completely vaporized, that plastic material. Degradation means complete loss of that plastic material. Degradation म्हणजे नष्ट होणे. इथं काय सांगतो आपण, the melting point of thermoplastic is lower than the degradation point. Degradation point means that material will be completely vanished. Means its melting point is lower than that degradation point. Means before it gets vaporized, it will melt. लक्षात येत आहे, आपण लक्षात येत म्हणजे तो completely vanish होण्याच्या अगोदर तो वितळतो. But in case of thermosetting materials, its melting point you can say is higher than the degradation point. Means before reaching to the melting point, that material will get vanished. Melting point म्हणजे वितळाच्या अगोदर ते नष्ट होऊन जातं thermosetting material. Then these thermoplastics are available in the form of small pellets. Small pellets means very. Have you seen that chocolates, that germ chocolate is there? Small tablets form of pellets. You can say, have you seen that homeopathy tablets? Homeopathy tablets, have you seen? In small pellets. That raw material or this thermoplastic material, they will be in the form of pellets. Okay. Then in solid state, their structure consists of hard crystalline region together with the your amorphous region. Okay, some definite crystal structure will be there. This amorphous region means definite crystal structure is not present. Means in solid state, they are having definite structure. Whenever they are in solid state, some definite structure will be there. As we have discussed in the steels, low carbon steel, it has some ferrite and pearlite like that. Some definite structure will be there. So after this, the properties of thermosets, they have strong chemical bond. Already I have shown you that diagram. Strong chemical bond is there between the molecules and includes cross-linking. Okay, cross-linking. This is the cross-linking. Okay, here if you observe this, there is linear bonding. Are you getting this? Only one chain is there. This is one chain. Means one chain is not connected to the other chain. Okay, here you can see linear bonding is there. This is only a single linear chain is there. This is thermoplastic, but in case of thermosetting plastic material, this is a linear chain and it is attached to another linear chain. Are you getting this? One linear chain is attached to other linear chain here. This is cross-linking. This is linear bonding, and one linear chain is attached to another chain with this cross-linking. That's why these are having strong bonds. It's very difficult to break this bond, this cross-linking bond. That point I have added here. They have strong chemical bond between the molecules, including cross-linking, due to which they do not separate on heating. And this kind of bond is not there in the thermoplastic material. Then here two-stage polymerization will occur. How it will occur, that I will explain in the next session. Okay. Then they are hard and brittle. They are hard and brittle. Then they do not dissolve in the organic solvents. Then on heating, these thermoset polymers will char. They does not melt. What will happen here? If you provide heat, they will become hard. These materials, after providing heat, they will get hardened. With very small time gap, they will get hardened. Okay, and they does not melt very easily. Then their degradation point is lower than their melting point. Degradation point is lower than their melting point. Then the thermosets are in liquid state before doing their processing. This will be in liquid state only. And in thermoplastic material, they are in solid state. Before processing, they are in solid state, and these are in liquid state. Then when solid, their structure consists of thermostatic resins. Okay, this I will show you in the during the practical. We are having one resin material that I will show there. You will get means how that thermosetting materials are there. Okay, when resin material is there, practically I will show you. Okay, means we are not having that practical in our syllabus, but that material is available. That material I will show you. Okay. Epoxy resin material is there. Okay, these are some advantages and disadvantages. These I have added for your extra information. You can go through these slides. I will provide you whichever part I have explained. That is added here. Okay. If time permits, I will take it in short. Okay. These thermoplastic, this is not part of your syllabus. Just comparison part is there. Please go through this. Okay, I have added here already points. I have explained. Okay, same points are there. Degradation at constant temperature, like this. Simple points are there. Just they have separated their advantages and disadvantages. Please go through this. Now, after this, this is the comparison between thermosetting plastics and thermoplastic materials. Here, first point you have to add related to its definition. What is the thermoplastic material and what is thermosetting plastic material? Okay, here, please see here. Okay, initially it may be liquid or semi-solid or powder, which solidify on heating for first time, and then it will decompose on heating to the high temperatures. Okay, means you can heat only once. Once it is heated and hardened, after that you cannot change its shape. That is thermosetting plastic material. Okay. Then thermoplastic materials repeatedly soften when heated and harden when cooled. When you provide heat, it will become soft and you can give the shape like this. Here what will happen? You can give heat once, okay, and after heating, once it is hardened or solidified, after that you cannot change its shape. That is thermosetting plastic. Then here, the second point, chemical change is not reversible. Okay, chemical change is not reversible. Means only once we are heating and hardening it, then we cannot reverse it. In this second case, that is thermoplastic material, you are repeating that process, means whichever chemical changes are occurring that are reversible. Chemical changes is reversible, or whichever chemical changes are there that are reversible in nature. Then these plastics are prepared by condensation polymerization, and these plastics are prepared by addition polymerization. Just remember the name. I will explain it in that polymerization session, because here you will not able to understand it, because that polymerization is little complex process. Okay, just try to remember this. Means these two are formed by different polymerizations. For forming this thermosetting plastic material, condensation polymerization is required, and here addition polymerization is required. Then formation of water occurs. Means why this water is forming? Due to condensation polymerization, this water is forming. And here this addition polymerization is occurring. That's why water is not formed. Means what point you have to remember here? It is formed due to condensation polymerization, and byproduct will be water. And here addition polymerization will be there, and no byproducts are there. Okay, different slides are there. I'll show you that. Here, addition polymerization. Monomers are added together with no other products. Monomers म्हणजे काय असतात तर small units or molecules. Number of molecules will come together. That process is polymerization. In short, number of molecules are there. Suppose 10-15 molecules are there, and they are linked to one another. That is considered as polymerization. That single molecule will be considered as monomer. And if we are linking the number of monomers together, that will be polymerization. Are you getting this? And if in this polymerization process, if any byproduct is formed like water, then that process is condensation polymerization. And if no other byproduct is formed, then it is addition polymerization. Okay. Then in case of your thermoplastics, addition polymerization is there and no other products like water. Okay, means water formation does not occur here. And in case of thermosetting plastic materials, water will be formed. Water will be formed. Okay, for this means for polymerization, some monomer, polymers, these concepts are there that I will explain it later. Okay. Okay. Are you getting these points? Condensation, polymerization, then byproducts like waters are formed here. Then these thermosetting plastic materials, they have higher load carrying capacity. These are having higher load carrying capacity, and these thermoplastics have low load carrying capacity. Why load carrying capacity is high here? For all properties related issues, please refer that diagram, this diagram. Okay, this is thermosetting material. This is thermoplastic material. Here bond is weak. That's why its strength is low. Here this bond is very strong due to this cross-linking. That's why it's what will happen? Load carrying capacity is high and it is also hard in nature. Okay, means all that differentiating points you can write from this diagram only. Just try to remember this diagram. Okay, here they have higher load carrying capacity, okay, due to their cross linking of the bonds. Then they have low load carrying capacity. Then these are more hard, strong, and brittle in nature. These are soft, weak, and less brittle in nature. Then these are insoluble in organic solvents. These are soluble in organic solvents. All these characteristics are due to that linking only, bond between the molecules. Then higher melting point and high strength. This is due to that cross-linking bond only. These are having low melting points and low strength. Okay, here that property is mentioned. Thermosets are having cross-linked polymers, and these thermoplasts are having linear and branched linear polymers. Okay, only linear bonding is there, and due to this linear bonding, they are having low melting point, low strength. Then these are soluble in easily soluble in organic solvents, low load carrying capacity. They are soft in nature. Okay, all these properties will be related to that bond only. And in case of thermosetting plastic material, due to this cross-linked bonding, they are having high melting point, they have high strength, then they are insoluble in organic solvents, then they are hard and stronger in nature, their load carrying capacity is very high. Okay, all these characteristics or properties are there due to that cross-linking. Then some examples of thermosetting plastic materials: epoxy resins, then bakelite, polyurethanes, urea formaldehyde, melamine formaldehyde. These are examples of thermosetting plastic materials. And in case of thermoplastic materials, polyethylene, polypropylene, then PVC, that is polyvinyl chloride, then polystyrene. These are examples of thermoplastic materials. Okay, whichever plastic bottles are there, you are drinking the water in that plastic bottles. That plastic bottles are example of these thermoplastics. And as far as these thermosetting plastic materials are concerned, that plastic dishes are there in your kitchen. Dish, it is a little bit hard and strong in nature. Once if it is falling from your hand, it will get break. It is little brittle in nature. That plastic dishes, or you can say these kind of plastic switches are there. Plastic switches. These are manufactured from thermosetting plastic materials. Are you getting this? We are having brief discussion related to its applications that we will discuss in the next sessions. Okay. In this today's session, we have covered this point, the what is the meaning of this plastic material, and all kinds of it. I think time is over. If any queries there, please ask me. Those who are attending through the online platform, please enter your roll number in the chat box for attendance purpose. Be quick. If you are having any difficulty, you can mention that in the chat box. And if no difficulty is there, please mention your roll number in the chat box for attendance purpose. Okay, thank you for attending this session. You can leave now. Thank you. You can leave this session and you can join your next session at 3:30 p.m. Thank you.